Okay, so here's our review. So tomorrow we have a quiz, and if we can go through this, we're going to be in pretty good shape, all right? And again, I'll give you a note card when we're done, and you can use your note card to put down the important stuff. But number one, list 5 numbers in each set. Well, natural numbers are basically like a 1, 2, 3, 4, 5, dot, dot, dot. So there's at least 5 numbers, right? The natural numbers are, you know, the counting numbers, what they're called. The whole numbers, the only difference between the whole numbers, the only difference is the 0. It's the only difference between the natural numbers and the whole numbers is the inclusion of 0. So it's just 0. 1, 2, 3, 4, dot, dot, dot. Integers, well, integers can be fractions. I'm sorry, I said that wrong. Integers are positive, negative, whole numbers. So maybe, I don't know, negative 3, negative 2, negative 1, 0, 1, 2, and of course there's a whole bunch more, but you know the directions say just list 5. So rational numbers are any number that's a fraction. So we can list 5. I could list 1/3. 0.5 would be a fraction, right? 1/2. 7, that could be a fraction. 7/1. Well, I don't know, negative 2. I don't know, anybody have one they want to throw up there for rational numbers?
Pi.
No, pi's not. But hang on to that one for the next one. Yeah. Give me. Anybody have one more? One more? 4. Why not? 4 is a rational number. Sure. Great. Now, irrationals. What do you want to do? Gianna?
Pi.
Pi would be an irrational number. Square root of 2. Any square root number that's not a perfect square would be an irrational number. Like maybe square root of 3, square root of 7. I don't know. Maybe square root of, I don't know. Give me a number. I don't care. 32. That works. There you go. Okay. Everybody good? Unless it's a perfect square. Okay, so we're going to graph this. Graph this set. Now, on this little symbol has an equal sign. So negative 4. I'm going to put negative 4 on my. I'm going to put 7, and I'll put 8. I could put 0 in there, but I don't need to. I just really need to list the numbers that are on the set. All right. So I'm going to put a solid dot at negative 4 because it's equal to it, okay? Solid dot. Open circle at 7. Open circle at 8, okay? It does not have a little equal sign on 7. Does not include 7. Does not include 8. Now, let's read it. So it says, if I read x backwards, it says x is greater than negative 4. Well, that means this way. But at the same time, it's going to be less than 7, so it shades in between 7 and negative 4. Or we're going to be greater than 8. Well, that's 8, 9, 10, 11, all the way to infinity, right? So I'm just going to make this go a nice dark arrow like that. Okay. Thumbs up? Does that seem pretty easy? Okay, good. All right. Number 7. I can count, really. F of 0, it's just a question. It means just to plug in 0. So I'm going to go, all right, F of 0. Yeah. Oh, I haven't done that. Thank you. Interval notation. Thank you. Back up to 6. Okay, bracket, negative 4, comma, 7, parentheses. So it's a bracket if it's a solid dot. It's a parentheses if it's an open circle. Okay, then we go or. And we'll go parentheses 8, comma, infinity, parentheses. So it's a bracket if it's a solid dot, parentheses if it's an open dot. Infinity will always be a parentheses because you can never get to infinity to make a solid dot. Okay. Okay, back to 7. 2 questions. F of 0 means just plug in 0. That's all I'm going to do. Plug in 0. So F of 0 is equal to 2 times 0 squared minus 4 times 0 plus 5. If I evaluate that, then F of 0, and you can use a calculator if you want to, but I know 0, I know the answer is 5. I might use a calculator for the next one, just because let the calculator do the work, right? So the next one is F of negative 2, so I'm going to plug negative 2 in. So I'll go F of negative 2 is equal to 2 times negative 2 squared minus 4 times negative 2 plus 5. And I'm really going to use my calculator. I'm a little lazy sometimes, but I also make mistakes. And if I use my calculator, I'm probably not going to make mistakes. I'm just going to go parentheses 2, negative 2 squared, subtract 4 times negative 2 plus 5, right? Just put the whole thing in the calculator. So much easier, right? And then I get an answer of 21, okay? Everybody, that's the best way I think to do it. I know you can plug numbers in, but I usually make mistakes, and I don't want to make mistakes, okay? Okay. Okay, square roots. We can do this. Okay, number 8. 48. So you could go 4 and 12. You could go 4 and 12, and then you could break down 12 again into 4 and 3. I'm going to shortcut it. I'm going to go 16 and 3. I just happen to know that. 16 times 3 makes 48. So for me, it's faster if I go the square root of 16 times the square root of 3. 16 is a perfect square. So the square root of 16 is 4 times the square root of 3. Don't take the square root of 4. Don't take the square root of 4. It's just a whole number called 4. Leave it as a 4. Don't take the square root of that number, okay? So the answer is just 20 square roots of 3. Kids will do that. They'll see a 4 and take the square root of it, but don't do that. There's no square root symbol. 9. Let's multiply the whole numbers. So I get a 12 square roots of 12. I can break down 12 into the square root of 4 times the square root of 3. Square root of 4, I can do that. That's a 2. I get 12 times 2 square roots of 3. I can multiply the whole numbers. Get a 24 square roots of 3. Thumbs up? Yeah? Everybody good? Okay. All right, 10. So with exponents, I want to take half. You want to take half the exponent. And if it's odd, we'll take one away and make it even, okay? But this one's not too bad because they are even numbers. But I'll break down 32 first. I'll break down 32 into 16 times square root of 2. And then I'll take half of this. X2, Y6. Okay, I'll just take half the exponent, right? Square root of 16 is 4. I've already taken half of this one, x squared. I've already taken half of that, y6. But the square root of 2 is really just an ugly decimal. Square root of 2 is just the square root of 2. So we'll leave that answer like it is. We'll go 4 x squared, y to the 6 square root of 2. Okay, thumbs up, pretty good. Okay, 11. So whenever I see a fraction with square roots, I just write as two separate fractions. I'll just simply write as the square root of 25 times the square root of 3. I'll just break it up. Square root fraction, square root fraction. I'll just write as two separate parts. Now, what we've learned in here is you can't have a square at the bottom. So the trick I taught you is to fix the problem with the problem. The problem is the square root of 3. So I multiply by square root of 3, square root of 3, okay? Okay, how's that going to help me? Well, nothing on top. I'm going to get the square root of 75, or I'll get 5 square roots of 3. You guys agree with the 5 square roots of 3? Square root of 25? It's 5. And then on the bottom, we'll get the square root of 9. The square root of 9 is just 3. See, I did that. I got the square root of 9. The square root of 9 is just 3. Kind of skipped a step, but we've been doing that one for a while, haven't we? All right, 12. This one's like our warm-up. I'm going to go 2 to the 5th power. X to the, multiply the exponents, negative 15, y to the 10th, all right? Now I can do more. 2 to the 5th power is not 10. 2 to the 5th power is not 10. 2 times 2 times 2 times 2 times 10. So it's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And if you're not sure, you can always do that on your calculator also, but you can, watch. You could do 2 to the 5th power, right? 32, oops, can't see that. Okay, so my whole number is 32. I'm going to bring the x to the 15 down, so next to the positive 15, and the y to the 10 stays on top. How am I doing? Okay, 13, very similar to 12. Let's multiply the whole numbers together first. I'm going to get a 12. X, I'm going to add exponents. I'm going to add, so I get an x to the 2 and a y to the negative 1. And then all I'm going to do is bring the y down, okay? So I'll rewrite this as a 12x squared over, and I'll bring down the y to the 1. How am I doing? Okay, 14. So let me tackle the whole numbers. Make a fraction bar because I can see I've got some negative exponents. So 12 divided by 6, that's just 2. I'm going to bring up the x3. I'm going to bring down the y5. Okay, I have more work to do, but I want to show you what I've done. I just moved the negatives. x3 came up, y negative 5 came down, okay? Now, the x4, it stays exactly where it's at. It's positive. And then I've got a y negative 2. It's got to come up, right? To y2. So I moved all of my negatives. If it's negative, I moved it up or down. Whatever it happens to be, if it's a negative exponent, it has to move, right? Okay, from here, after I've done that, I combine these and make that a x7. So I'm going to have a 2x to the 7th. And then I'm going to divide the y. So 2 of these y's will cancel 2 of these y's. We'll be left with y to the 3rd. How's that? We're getting better at those, aren't we? Maybe? Maybe a little bit better? Hopefully by the time we hit the end of the year, you guys are going to be able to do these. Hopefully by tomorrow, you'll be able to do these, right? All right. Turn the page. Okay, domain. Here it is. How wide is this graph? It goes from what to what? It goes from what to what? Let's see. It goes from negative 3, right, to 1, 2, 3, 4, 5, 6. It goes from negative 3 to 6, doesn't it? That is its domain. It exists between negative 3 to 3. So in interval notation, the domain, okay, is simply going to be negative 3, comma 6. Now I used a parentheses and a bracket. Parentheses because it doesn't exactly equal negative 3. It's an open circle. I use a bracket 6 because it's a solid dot, okay? Range. Reach for your range. So do the range. I'm looking for the very lowest value. The very lowest value is negative 3 to its highest value, which is a positive 3. It starts at the lowest value of negative 3. It goes up to its highest value of 3. That's all range is. Reach for your range. Don't mess with my domain, okay? All right, now, number 16. I'm going to need some graph paper. And I don't know if you guys have graph paper or not, but if you need graph paper, I could pass them around. Anybody need graph paper? Okay. Paper, come pass that around. Graph paper, I'll give you extra in case somebody will pass it around. Graph paper, just pass it around. There you go. I think we have plenty. Okay? All right. Okay, 16. So, before I do 16, over on my little column, my little side column, I'm going to put the parent graph. The parent graph is a parabola, right? 1, 1, 2, 4. Okay, here's my parent function. That's my parent function of x squared, okay? That's that one right there. So the way I graph it, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, right? That's just a parabola. And of course it's symmetrical, so negative 1 squared is 1, negative 2 squared is 4, and negative 3 squared is 9. So that's my parent function. If this is fx, then I'm going to take fx and I'm going to move it. Now I'm going to do the opposite. Remember, it's the opposite of the inside. Opposite. Make yourself a note. Opposite. Okay? Opposite. You're going to do the opposite operation of the inside. So instead of going forward 3, we're going to go, instead of going forward 4, we're going to go back 4. So my vertex, the vertex of this parabola is at negative 4, 3. So the inside number changes. And John and I were talking about the reason why is that's the value that would zero it out, right? That would make it as the very bottom point. So to do 16a, I'm going to go to negative 4, 1, 2, 3, 4, 1, 2, 3, and graph my parabola in. Well, I'm going to probably run off my graph paper, but that's okay. 1, 1, 2, 4, and of course the rest is off my paper, but there it is right there. There's A. So I went to the vertex, negative 4, 3. It's a parabola. 1 squared is 1, 2 squared is 4, 3 squared is 9, which I didn't make my graph paper big enough. 1 squared, negative 1 squared is 1, negative 2 squared is 4, negative 3 squared, again I didn't make my graph paper big enough, but okay, B, let's do B. So to do B, we're just going to take our parent function and make it upside down. So we're going to reflect it over the x-axis. So reflect over x-axis, okay? That. Like that. So we're going to go ahead and draw it in like this. We'll go our 0, 0, we'll go 1, 1, but upside down, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 3 squared is 9. And of course it's symmetrical. So I'll have another value at negative 1, negative 1. Symmetrical. I'll have another value here and another value here. C, am I going too fast? Am I okay? Am I to wait for a second? I don't mind waiting at all. Okay. C, we're going to have 3 of f of x. So we're going to take our parabola and just make it 3 times as tall. So I'm not going to get all of it for sure. I mean, I'm going to get as much of it as I can, but it's going to be real tall. So 0, 0, because 3 times as tall as 0 is still 0. 1, 1, but I got to go 3 times as tall, so let's go 1, 1. I'm going to go 1, 3. 2, 4, but instead of going 4, I'm going to go to 12, right? 3 times as tall, so it's going to be off the page. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 3, 9, which would put me up to 27, but that's not going to fit on my paper, right? So it's pretty tall, so I've got another point here, another point here. There we go. Okay. And I can't fit the rest of the points on. It'd be just way too tall for me. How am I doing? Okay. Everybody get it? Okay. All right. A. Is this a function? Yes or no?
No.
Why do you say no?
There's 2 2's for x.
Nice answer. 2 is paired to 1 and the 2 is paired to 2, so you have 2 values for x. Well said, Jonna. No, it's right here. 2 goes to 1 and 2 goes to 2. So is 2 lattes going to cost you $1? Is 2 lattes going to cost you $2? It's rather confusing, isn't it? Right? Nice job. Is B a function?
Yes.
Yes, because it would pass the vertical line test. Every x value has one unique y value. Good. C.
Yes.
Yes, every x value has a unique y value. Yes, it passes the vertical line test. Good. Now, 17. There are 2 ways to do 17. The book wants you to multiply these numbers and add exponents. Okay, the book wants you to multiply the big numbers and add the exponents. Me, I really believe the easiest way to do it, because you're kids, is just you let your calculator do the work. So we'll go parentheses. Let me clear that. Parentheses 4.1 times 10 to the power of 5 parentheses, right? See what I'm doing? Parentheses 3.8 times 10 to the power of 6, okay? Enter. Now what does that mean? E12. What does this E12 mean? Yeah. So it's going to be 1.558. Nice job, Angel. It is. So my answer is going to be a 1.558. You must put times 10. Don't forget the 10 to the 12th. Don't forget the 10, because the E means, like Angel said, that's my exponents, times 10. Don't forget the 10, because the calculator does not write the 10, does it? Okay. Okay, same thing on number 18. The book would like you to divide these and subtract exponents, but when you have a calculator, why not just use the calculator? I'm going to go parentheses. 3.6 times 10 to the power of 4, parentheses divided by parentheses. 6 times 10 to the power of 12. Okay. 6e negative 9 will be the wrong answer, won't it? 6e negative 9 will definitely be the wrong answer. It is 6 times 10 to the negative 9. Okay, you need that 10 in there to get it right. Easy? Okay, so we don't have a lot of homework, but I still want you to do this assignment. It'll help get you ready for the quiz, because I didn't cover everything on here because I didn't want to give like a hour-long lesson. But the homework will help fill in some of the gaps, okay?